Uh, okay, so hello everyone. My name is Iman, and I'm thrilled to be your guide on this exploration into the fascinating world of artificial intelligence. I am actually one of the two machine learning leads for the Google Developer Student Clubs here at IIIT Kalyani, alongside Tomogno, who will also be taking some of your sessions. And it's my pleasure to take you through uh, this journey that starts from the very definition of AI, and then we proceed to its real life, real world applications. We proceed through some small demos that we'll also be showing you. I also hope you had a good time with all of the previous tech talks that was organized. And I hope that this session will also be very informative and good for all of you. So, uh, AI actually these days it's a very hot topic, right? A lot of people want to learn about it. A lot of people believe that there is a lot of career opportunities in this field. Um, one of the biggest reasons, one of the biggest sort of one of the biggest reasons why it's so popular these days is actually ChatGPT. I'm pretty sure many of you are familiar with this product. Many of you have used it. Many of you are used to it. You have gotten sort of accustomed to how to using it. Um, it's developed by OpenAI. It's a very popular product. I think it was one of the fastest growing applications as well for quite some time. And that was actually the launch of ChatGPT was sort of the catalyst that started this entire craze about AI these days. Um, I mean, like nowadays, not just people in the industry, like people in this computer science industry are talking about AI, but even normal people are slowly becoming familiar with what AI is. Uh, many companies these days do like they make it a very important point to always put the word AI in their marketing material because that gets all of the viewerships, that gets all the views and all. Um, so yeah, let's dive right into AI. So, give me 1 second. Okay, so here is the introduction to AI/ML. So, yeah, so first of all, let's start with this. So, what is AI? Well, AI, the word AI actually stands for artificial intelligence. We all know that. Um, the word artificial intelligence is very self-explanatory. Like artificial is something that is not natural, and intelligence is, the ability to think, the ability to learn, the ability to understand. It is one of the key features that actually makes us human beings different from computers, because computers, they may be able to perform calculations, they may be able to do certain operations faster than us, but after all, they are not intelligent machines. They don't have emotions, they don't have the ability to understand things, right? In that sense, in the way we human beings understand things. um, so, like AI fundamentally is just a branch of computer science that is dedicated to creating machines that can perform tasks that typically require human intelligence. So these tasks can be, anything from problem solving to decision making to understanding natural language, recognizing patterns. All of these things come under the domain of AI because fundamentally all of these things that I just told you, they were done by human beings, and they you know they are traditionally these tasks require uh, a human intelligence. These tasks require human intelligence. AI basically uh, sort of tries to emulate all of those things into software. So this is the definition of AI. Now let's talk about these two terms. These are so ML and DL. ML actually stands for machine learning, and DL stands for deep learning. So, machine learning is basically a subset of AI that empowers machines to learn from data without explicit programming. So, well, let's take an example. We all know how to identify what a dog looks like, right? If you ever walk down the street and you look at a dog, you'll be able to very easily say, "Ki, okay, that is a dog," right? Now, if I asked you, how can you identify it's a dog? Will you tell me, ki, okay, I looked at the shape of the eyes. It was of a specific shape. The nose was of a specific shape. The tail was of a specific shape. The length of the foot was this much inches or this much feet. Will you ever tell me that? Obviously not, right? The simple reason why you understand what a dog looks like is because you have simply seen so many images of a dog. So your brain actually has a general idea about what a dog looks like. So that is sort of what machine learning does, right? What it does is it looks at data and it tries to understand, it tries to identify patterns in that data, and through those patterns it basically learns what the data is trying to communicate. So just like by seeing different images of the dog, your brain understood what a dog looks like. Similarly, a machine learning model can look at different kinds of data and make certain inferences from it, right? That is what machine learning is. Okay, so now let's talk about deep learning. So, deep learning is basically a very specialized form of machine learning which is inspired by the neural networks of the human brain, which allows machines to tackle complex tasks like image and speech recognition. So, first, let me talk about what a neuron is. Now, let's, for now, let's stop talking about computers. Let's talk about humans. Let's talk about the brains that we have. Now, basically, there are uh, there are these things called neurons, which are basically the fundamental units of our brain and our central nervous system. I'm pretty sure many of you have studied it already. So you have a basic idea that these neurons basically are used for transmitting signals, electrical signals all over our body. So why are we talking about neurons? Because when when the invention of AI started first, people had this idea that what we can do is just like human beings have neurons in their brains, which are responsible for thinking and intelligence and all of those things, we can emulate that neuron in a computer in order to create an artificial neural network, right? And a neural network is basically just a connections between all of these neurons. And when you have a lot of these neurons and you have all of the connections between them, you get a full neural network, right? We're going to get into details about it in upcoming sessions later on. Uh, but for now, you understand that in deep learning, we use these neurons and we use them to create neural networks. And using these neural networks, we learn, we train the machine, we make the machine learn whatever we want it to learn. Okay, so that is what deep learning is. Uh, Now let's yeah, so that is what deep learning is. So this is basically just a small comparison about AI, ML, and DL. So you can use this image to understand which is a subset of which. So machine learning is basically a subset of artificial intelligence. Deep learning is further a subset of machine learning. So it's quite simple to understand. I actually said it here because these terms are used a little interchangeably all over the industry, and they do have separate meanings, and it's important to understand these separate meanings. So now let's talk about AI in daily life. So, AI is something that already has actually become a part of our life. Many of us have not realized it, many of us have realized it, right? But we cannot live without it. It is something that we have gotten very much used to and very much comfortable working with. So let's talk about a few of these topics. So first of all, it's healthcare. Um, I think I have that in my slides. Yeah. So this thing I actually found on at an IBM article about AI in healthcare. So you can see that the AI healthcare market is currently valued at $11 billion in 21. That is projected to be worth $187 billion, which is quite a jump in 9 years. Um, so machine learning in healthcare specifically, actually, ML is still very much in its research phases. You can see this $11 billion figure is definitely not a small figure. So a little bit of usage is still happening in the healthcare industry, but still, it is not very popular. Like if you ever go at a hospital, you won't find robots treating you, right? So it is still very much under research, and there is tremendous opportunity here. People are working tirelessly behind these kinds of fields. Yeah, so now let's talk about fitness. So this fitness topic is actually not, like uh, basically in fitness what happens is like we have virtual trainers. That could be an example where these virtual trainers basically they based on multiple data like your weight, your diet preferences, your health conditions, or based on all of this, these AI powered trainers sort of give custom workout routines. They can also give custom food recommendations and all. So that is one application in which AI virtual trainers are being used. Uh, there are plenty of applications as well, which are basically mental health applications, where what we do is it is basically like a chatbot, which is specifically designed to give you mental health advice. So a lot of people just come up to the platform and talk with this AI, and the AI gives them advice. So that is another place where it is used. So that is also under healthcare. So healthcare and fitness is taken into consideration. Virtual assistants, as I said, in this where this virtual assistant uh, is useful for fitness as well. The virtual assistant, another virtual assistant that we are familiar with is actually the devices that we have like Amazon Echo, Google Home, all of those devices which use natural language processing in order to understand and respond to voice commands and do all of the tasks that we tell it to do. There is also a lot of privacy concerns regarding these devices like Amazon Echo, Google Home. Uh, like a lot of people say ki these devices basically have their microphones always on. So anytime they are in your device, anytime they are in your room, they're basically listening to all of the conversations that are going on. So that scares a few people. Then there is another topic which is basically language translation, where NLP, which is natural language processing, actually is used to for translating language. Like we all have used Google Translate before, even though Google's Translate's responses are sometimes hilarious and they're quite inaccurate. But language translation is still something that AI can be used for. Um, Another thing that we I want to talk about is entertainment. So, entertainment, under entertainment, basically a specific type of ML algorithm called a recommender system comes in. Recommender systems basically recommend stuff. So, let's say you open YouTube and you just go to youtube.com, and there you're going to find a list of videos on youtube.com. Now, YouTube actually has suggested those videos to you based on a lot of other factors, like what other videos you have watched previously, for how long have you watched those videos, because if you watch a video for a longer duration, that means you like that video, and if you like that video, YouTube can recommend videos like that to you, so that you stay in the platform, and the more you stay in the platform, the more money they make. So they obviously want you to stay in the platform. So, one very special thing about recommender systems that I talked about is these recommender systems are very, very important for today's economy, because when you think about it, YouTube works on a recommender system, Instagram works on a recommender system, Netflix works on a recommender system. Recommender systems generate a lot of revenue for the companies where they're implemented, because they have a lot of economic value. I mean, you can understand that giving users custom content based on their recommendations is something that is quite important. So, yeah, recommender systems is done. Now, personalized experiences is again also recommender systems comes under that category as well. For personalized experiences, we can also talk about, like. Uh, what was that? Like the suggestions that Amazon gives you to purchase product. So it may not always be video-based content like YouTube or Instagram. It can also be Amazon recommending you products to buy. So that also happens through recommender system. That is also a form of personalized experience. So yeah. So yeah. So now we come across the types of machine learning. So there are primarily three types of machine learning. There is supervised learning, there is unsupervised learning, and there is reinforcement learning. We also have some other topics as well, like again I said recommender systems. Um, but when we talk about types of machine learning, mostly uh, these are the three major categories which come under. So let's get into details about one by one what each of these things are. So first, let's talk about supervised learning. So before starting the explanation, I would like to go back to that example that I gave a few minutes back, which is about the identifying a dog example. So I told you कि you do not identify a dog based on quantifiable features that you can see and understand, right? You don't look at the length of the dog's feet or the shape of the dog's ear or things like that. You understand the dog is a dog because you have simply seen way too many dogs, and your brain sort of has an idea what a dog looks like, right? That is how you identify dogs. Supervised learning is exactly the same thing. What happens is there is a set of data and you have a set of labels, right? Now, by looking at the data and the labels, the model sort of understands, tries to find a pattern between the label and the data, and based on that pattern, the model basically learns what the labels are. The model basically learns like a pattern between the data and the label. Okay, so let's try and understand this with an example. Okay, so you are seeing a column that is labeled X and a column labeled Y. Okay, this is a very simple example that we are all going to try and understand. So in supervised learning, what I said is you have a set of data that is given and a set of labels, right? Or not necessarily labels. You have a set of data and a corresponding set of values,
and you're trying to find the relationship between those two values, right? So let's look at this data for now. So in the X column, we have 1, 2, 3, 4, 5, 6, and so on. Let's say up to 285. Okay. And in the Y column, we have up to values uh, up to 570. So for X, we have 1, 2, 3, 4, 5, 6, 7, 8. For Y, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Right? Now, what I want you all to do is I want you to look at this data carefully and try and identify a pattern, a relationship between X and Y. Okay? Think about that for a second. So, the pattern, I'm pretty sure many of you have been able to figure out, is actually the values in Y is the values of X times 2, right? Because if you look closely, the values in Y is basically the value of X, which is 1, times 2, which is 2. Then the next value of 2 is actually the next value of Y is 4, which is 2 times 2, right? So similarly, if you notice carefully, all of the values of Y is actually their corresponding values of X times 2, right? So what you did here is you learned the relationship between X and Y, right? By looking at the data, you actually learned that Y is 2 times X. Does that make sense? So what you did just now is exactly what supervised learning is. We basically look at the data, right? And we try and figure out patterns between the data. So over here, like we have X and Y right now. There can be X1, X2, X3, X4, X5. There can be many features. These are actually called features. Like the technical term for X is actually features, and the technical term for Y is target, right? So you have features and you have targets. Now, basically, we can have many features, and all of those features can be related to their targets as well. Now over here, the relationship between the features and the target, if you look closely, is linear. What I mean by linear is it follows the pattern y equals constant times x. Uh, like if they're two, like if they're very complex for now, don't worry. We'll be taking sessions later on where I will teach you. I will also be giving you resources at the end of this session if you are interested in proceeding on your own. So basically, this relationship between all of the features and their targets can be anything. It can be linear, it can be quadratic, it can be cubic, it can be basically anything, right? What the model is supposed to learn is basically these relationships between the features and the targets. Okay, so now let's look at it in action. Okay, so now we are in VS Code and we are going to write some code. Okay, now uh, I will be using the programming language Python over right here. Generally speaking, for machine learning, Python and R are sort of like the most popular choices. Uh, R is also like not many people learn R. Python is primarily the go-to choice for ML because all of the famous machine learning libraries, all of the uh, work, a lot of work has actually already been done in Python. So that is why people prefer using Python. Python is also a very simple and easy language to learn and master. Um, so yeah, I will be using Python for this demonstration. The code that I will write may not make sense for now. Okay, because I this is not supposed to teach you, like today's session is not supposed to give you a solid understanding about what ML is. It is just an introduction. I just want to show you how things work. So I will be explaining as much as possible, right? But even if things don't make complete sense now, do not worry. Uh, as you learn more about machine learning, you will slowly and steadily understand what things are and what things are basically, what all of the things are. Okay, so yeah, what are it? Mm, yeah. So let's start. So what I'm going to do is I'm going to use a package which is called scikit-learn. This is a very popular package. It's a very popular Python package. A lot of functions a lot of functions for machine learning algorithms are already built into scikit-learn. So it makes things very easy. So I definitely suggest you guys maybe do a quick Google search yourself, or I think you will also find whole tutorials on scikit-learn on YouTube. So you can definitely look at them. So what I will do now is I will actually use this from what was it? Model selection. Uh, and okay, so what I did through these three lines is basically I called this linear regression sort of function through which we will be. This is linear regression is basically an algorithm through which uh, you know these where I said the relationship between the features and the targets is found out through linear regression. Basically, like you can find out those relationships between the features and the targets. I'm going to demonstrate how it happens in a few moments. This next line train test split function, this is actually called because um, let's say you have uh, data. Let's say you have a full data and you want to uh, like using that. Let's say you have a data constraint, right? You have limited amounts of data. Now, after training a model on that data, you also need to measure the performance of that model, right? You also need to understand how well the model is performing on that data. So if you, in order to understand that, you cannot use the entire training data in, you cannot use the entire data set for training. Because if you use the entire data set for training, now you do not have new values which which the model has not been trained on, right? Because ideally, what should happen is you should have some values that are only for training and some values that are only for testing, right? Because these the reason these testing values should be separate from the training values is because the model has already seen the output of the training values. So if you ask the model to predict the output for the data that is present in the training data, what the model will do is since the model has already seen the output, the model will already have an advantage into giving you the correct answer, right? So even if the model doesn't really understand the pattern, it may just simply say, oh, I have already learned this value, so I can just spit that value out. So when you are testing the performance of that model, you are not necessarily bringing in new data into the model. So what we generally do is we take the entire data set and we split it into two divisions. We split it into the training set and the test set, right? In many cases, we actually split the training data into training and cross-validation sets as well. But in many cases, it is also not necessary, but it is all, generally speaking, it's a good practice to split it into training set, cross-validation set, and test set. So what happens is you use the training set in order to build a base model, then you use the cross-validation set in order to sort of make the performance of the model better, and then you use the test set for final evaluation. Okay, so that is what this train test split does. It basically allows you to split the entire data set into all of these divisions. Okay, I hope that was clear. So firstly, what I'm going to do is I'm going to load the test.csv values. So here we have data.csv, so we'll just make it test. Now we're going to create the x values as well. Values dot reshape y equals to this is not necessary. Uh, so now uh, this you should also write this random state parameter. I will explain what all of these things are in a few minutes. Let me just write the code first. Uh, yeah, this should be okay. So what I have done is I have used this read CSV function in pandas. Another popular Python library is actually pandas. These are some very popular libraries that you will understand slowly and steadily as you uh, proceed through your journey of learning machine learning. You will you will hear many of these packages. You will hear about NumPy, you'll hear about pandas, you'll hear about matplotlib, right, which we will also be using while I demonstrate the unsupervised learning. So yeah, so what this has done is I have used this read CSV function in order to take the values of this test.csv. From there, I have extracted the values of this x and y column. I've extracted the values of the x and y column over here, as you can see. And after that, I have used this train test split to basically split the x into x train and x test. So that is basically the training set and the test set, as I explained earlier. So now you have the x train, x test, or y train, y test. Um, Now, what we are going to do is we are going to build the model. So like this, and train by train. So basically what I have done is I have just created the linear regression model, and I have basically extrain and like when I was telling you to find patterns between the x column and the y column, basically using this fit function, what I have done is I have told the model to find all of those relationships between the x and the y. So now that this training is done, what we are going to do is we are going to see how well the model can predict these values. So what I'm going to do is I'm going to first print this x test. I'm going to print the first 5 values x test. So uh, yeah. Mm, uh, okay, so over here, as I said, we have split the entire x column of the test of the CSV file into x train and x test. So what we are seeing here is basically the x test column, right? So if we just remove this, we can see the entire x test column. Basically, these are all of the values in the x test column that has been separated by this train test split function. So what we are going to do is we are going to see only a fraction of those values for now. So in this case, we are only going to see the first 5 values. Okay, so let's take a look at them. Now, what we are going to now remember, okay, I have told my model to learn the relationship between X train and Y train. Okay, so remember when we did this experiment ourselves, we learned that the relationship between X train and Y train, the relationship between X and Y is that Y equals 2X, right? We learned this from ourselves, correct? Now, let's see if the model has learned that or not, right? So what we are going to say is we are going to print model dot predict x test 5. Okay, so what we're telling the model to do is we are telling the model key, you take the values of this x test 5, you take these 5 values, and you tell me based on the relationship that you have discovered what the appropriate value of this of these of what the appropriate value of y should be if these values are x, right? Now remember, we discovered that if the value of y should always be 2 times x. So this if the model has learned the features correctly, the model will be able to predict if for each of these values of x, the value of y should actually be their double, right? I hope that makes sense. So let's see if that is the case. So now notice that the model has predicted for 117 the value is 234, which if you do the calculation is actually 117 times 2 is 234. For all of the values it's actually that. So for 39 it's 39 times 2 is 78, 213 times 2 is 426, 208 times 2 is 416, 199 times 2 is 398. So we have actually trained the model. The model has learned the relationship between X train and Y train. So this is what supervised learning is. The model, instead of me saying the model, ki this is the relationship, the model itself learned the relationship between X and Y. So this is what supervised learning is. So in supervised learning, what happens is your data set basically contains these features and their corresponding target values. And through that, the model gets trained and the model learns to learns the relationship between the features and the targets. Okay, so I hope this is clear. So now let's move on to unsupervised learning. So now we are going to talk about unsupervised learning. So in case of supervised learning, what happened was our features and our corresponding targets, both of them were already given to us, right? So so the model already had something to go off of. The model basically knew that I need to find out the relationship between these features and these targets. Now, in case of unsupervised learning, what happens is there is no target values, right? We don't have target values in unsupervised learning. What we have instead is we only have the features. We only have the input features. We only have the values of X, sort of. And what we are supposed to do is we are supposed to find out patterns within those values of X. So it doesn't necessarily, so unsupervised learning only deals with finding patterns. So we are learning the patterns within the data set. That is what unsupervised learning is. So like in unsupervised learning, we generally uh, the training of the model doesn't happen in a supervised manner. That is why it is called unsupervised learning. The model itself is supposed to find all of the hidden patterns. So let me demonstrate this first. Okay, so now we are going to try and understand unsupervised learning. So let me first generate some data in order to give you an idea key how to do all of this. So let's do uh, port plotlet display learning yeah. So comparison to what? So first of all, we are going to uh, create some data, okay? And I'm going to show you how this uh, data looks like. So yeah, so so this is the data set that we have generated, right? So what this data is it's basically like it is uh, it is basically a set of values between this x and this y. Now, in unsupervised learning, what I said is we don't have target values like that. In unsupervised learning, we only try and find out patterns between data. So imagine this is our data, right? So if I told you, okay, this is the data we have, and I told you to find out some patterns between this data, what would you do? Think about this for some time. If someone asked me this question, what I would tell them is the pattern is there are four distinct regions of like there are four distinct values, four distinct regions in this data set, and in those four distinct regions there are like clusters of values, right? So there are basically four different sort of clusters in this data, okay? So that is what unsupervised learning is. Without the label, what I did is I found out patterns between whatever data we have here. So in this case, the pattern is that there are four distinct clusters, right? Does that make sense? I think I don't think my cursor is visible. Just show the cursor. I hope my cursor is visible now here. My cursor is visible. So basically, there are, I was talking about four distinct regions. So this is the first region, this is the second region, this is the third region, and this is the fourth region. So these are the four distinct regions in this dataset. Now in unsupervised learning, the model will discover these four regions automatically, right? So that is what unsupervised learning is. Now, this entire process is actually going to happen through a process which is called k-means clustering. I don't want to go into the mathematics of k-means clustering now. Uh, there will be separate sessions for that. I just want to show you a quick demo of this k-means clustering algorithm. So I'll just write some code. Uh, so I'll just give it k-means uh, start centers, is the cluster centers, and labels is the labels. So now I'm just going to plot them. Scatters, labels, naturalist, area, centers, Yeah, this is also fine. Uh, let's give it a title. Just an X label. X label is Y. Dot agent. Okay. Uh, see, this is it's too bad. I'll just make sure key it's not visible properly actually. X equals it's not necessary. Like this. Yeah, I will give it a color of red. Maybe. Yeah. So now, so this is what the output of the model is. So notice what the model has done. The model has actually identified these four distinct regions and has colored them accordingly. And these X values are basically the centers of these distinct regions, right? So that is what unsupervised learning is. It is basically where we look at data and then within that data we try and find patterns. So this model has found the patterns within this data. Okay, so I hope that was clear. Uh, so now let's get into the third type of machine learning, which is reinforcement learning. Okay, so now let's talk about reinforcement learning. Now, in case of reinforcement learning, what happens is you have an agent, right? And what you do, that agent is basically, you can imagine the model, your ML model, to be that agent. And what you say is you firstly you define some some motions for that agent. You give you give a set of actions for that agent. They are actually called actions. Yeah. So basically you have an agent, and that agent is basically allowed to do a certain set of moves, which are actually called the actions. Now what you do is you tell that agent to to basically do actions, right? And anytime it does an action, if it does something that is favorable to you, that you want it to do, you give it a reward, right? And if it doesn't do that, what you do is you give it a punishment. So, and the idea of the agent is always trying to maximize its reward. So it always wants to have the maximum amount of reward. So anytime it does something that you want it to do, you give it a reward, and anytime it doesn't do it, you give it a punishment. Okay, so you reduce the reward. So it is very similar to, let's say there is a baby, right? And that baby is the baby is throwing something. Okay, let's say the baby has let's say the baby has some I don't know, some chocolate or something, and the baby is just throwing that chocolate away, right? So what you're going to do is you might scold the baby. You might say, okay, you shouldn't do it. That is a very, very bad thing. So you can scold that baby. So that scold that baby is sort of negative reinforcement, or not necessarily negative reinforcement, but what it is you're you're saying the baby you you shouldn't do it. Okay, and let's say if the baby listens to you, then you can give a reward to the baby. So the baby always wants to get more reward and receive less punishment, right? In a very similar manner, the model also tries to get more reward and less punishment. And through this nature of the model, what you do is you basically train the model. Anytime you allow the model to do all of these actions, and anytime it does something that you want it to do, you give it a reward. Anytime it doesn't do it, you give it a punishment. It is very simple. Now, actually, the code for reinforcement learning is a little large, so I don't want to uh, demonstrate it right now. Uh, there are going to be sessions later on about all of these topics where we are going to go into details about each of them. So even if you didn't quite understand what it is, don't worry. I will also be giving you resources again, as I said, towards the end of this session. So yeah, so this is basically like the three major topics of machine learning. You have supervised learning, you have unsupervised learning, and you have reinforcement learning. Give me 1 second. Yeah. So basically, AI, like just like anything in this world, AI also has its own challenges. AI also, uh, there are also there are many kinds of problems that actually have uh, come up due to the advent of AI. One of the most common problems is actually the fear that AI is going to take a lot of jobs, right? Many people have this thought. In fact, there are many people from our batch only who, who are a little pessimistic about things like this. Um, so, you know, uh, my personal view of it is, AI has the potential to replace human beings. Let's not kid ourselves, right? AI does have the potential to do that. But I don't think we are right now, we are in a position we should be afraid of it. Uh, we we are we can definitely, like, as science progresses, as this field slowly and steadily grows, uh, you know there are going to be discoveries, there are going to be new discoveries, and maybe some of some of these discoveries, maybe they may lead to our downfall, right? Who knows? But I think we are not at that position now. People may look at ChatGPT and think ki, oh, ChatGPT has, ChatGPT can think, ChatGPT has emotions and all. But no, ChatGPT really, the only thing that ChatGPT can do is figure out patterns in speech and learn from those speech patterns. Um, so yeah, this is one of the challenges that has also come with AI. Uh, Another huge challenge. Now, this is not like another huge challenge with AI is AI requires data. AI requires a lot of data because the more the data, the better the AI's performance going to be. Performance is going to be, and with these uh, like when you have a higher need of data, what happens is many companies actually tend to violate people's privacy uh, because they want to because they want to get this data. Sometimes this data can be obtained in very unethical ways as well. If you can, I'm pretty sure if you just see Google data, if you Google some data privacy issues of Amazon or data privacy issues regarding Google itself, if you just search somewhere regarding these things, you're going to find a lot of articles. Many of it is going to be, many of it might be a bit scary for some of you, right? Uh, there was also, I remember seeing an image of Mark Zuckerberg, right? It was a very old image where he basically had a sort of sellotape over the webcam of his laptop. So that made a lot of people crazy. Many people thought that, oh my God, Mark Zuckerberg is taking this much care of himself, so we also need to take this much care of himself, this much care of ourselves. So whenever you have a large need of data, whenever you need a lot of data for any purposes whatsoever, uh, collection of data becomes an issue. In many cases, you don't even know if the collection is happening in ethical ways or not, right? So that is one of the biggest problems. So AI requires a lot of data. So another thing, like alongside this large amount of data collection that is necessary, uh, another problem that can happen with data is actually the presence of biased data. So in many cases, data may be biased. Data can be, you know, it can be biased in many ways. It can reinforce societal prejudices. It can lead to unfair decision making. It can lead to a lot of stuff. So not only is the collection of data very much necessary, we also need to take care of the fact that this data is not biased, this data is proper, this data is genuine, and these things are very, very important. Another problem with another challenge with AI is actually what is known as the black box problem. So what happens is sometimes when you have models that are very, very complex, uh, you don't necessarily understand how the model is actually working. You can have an idea about the architecture, you can have an idea about all of those things, but you do not fundamentally understand how the decisions are being made, what what is actually happening underneath the model. So what happens is anytime a model gets this complex, we just say ki, we just use the term black box because we don't know what is inside that box. So that's why it's a black box. So this black box problem also happens uh, in many industries where this transparency, this understanding is needed. This black box problem is a very big challenge because let's say you're working in finance, right? And you have an ML model which detects fraud. So, using a series of features, using a lot of data, it basically identifies whether a transaction is fraudulent or not. So, if the if you have a black box model, right? Let's say you want to go to a regulator and you want to prove that this is a fraud. You cannot just say, okay, I have this piece of software and this piece of software has said that it's fraud, so it's fraud. No, you cannot say that. If you're going to a regulator, you need to there is a possibility you need to explain. The regulator may ask you, okay, uh, this model is predicting, but what is it doing exactly? How is it making that decision? So it is important. So this black box model is not always helpful. So this is also another problem. In certain cases, AI becomes so complex, it automatically falls under this black box category, and it's difficult to make judgments about how all of this, how the model is making its decisions, how it's making its predictions. So yeah, these are some of the challenges and limitations of AI. Now let's talk about the future. Let's talk about how yeah. So now let's talk about the future. Let's talk about the future of AI. AI is actually a very growing field, and there is a lot of opportunity in this specific field. As I've already mentioned before, um, there are plenty of fields where AI is used. For example, AI is used in education. Uh, you can have uh, AI that gives you better ways of learning a simple thing. So there is a lot of opportunity. AI also has a lot of potential in finance. As I said, it can be used by banks in detecting fraudulent transactions. It can be used to disrupt traditional trading and investing practices. So there could be people can use AI for building their financial portfolios, for trading in the stock market, things like that. Yeah, so AI can also be used in military. AI can also be used for cybersecurity. AI can be used for advertising. Again, uh, as I said, advertising is basically dependent on showing you content which you like. And as far as showing you content that you like, I already talked about recommender systems, which can be used for that. So yeah, AI has a lot of potential in the future. Uh, it is a very growing industry. A lot of people are getting into it. Uh, yeah, so AI has a very bright future. So now I told you some of the resources that I'm going to give. So first and foremost is Andrew Ng's deeplearning.ai courses. This is something that I really suggest you all Google. You should definitely Google this. You will get a lot of value from this. Like this, you can just Google Andrew Ng deeplearning.ai and you will probably get a list of his courses. There are courses on supervised learning, unsupervised learning, all of the things that I discussed today. There is a machine learning specialization, there is a deep learning specialization. You can do all of those things, they are very good. Another thing that I found is actually roadmap.sh. So let me just open up a new tab and show you roadmap.sh. So in roadmap.sh in this website, you have this AI and data scientist roadmap, which you can really open and just go through. This is incredibly detailed, and I have seen it's very good. It's not at all bad. This is something that you should definitely follow. There is a lot of stuff you're going to, it is going to take you some time to do this. But again, this is also something that is very good, and that is something that, in my opinion, all of you should do. So I think that's pretty much it. I mean, the roadmap.sh roadmap is very large. There is a lot of details there. So I hope you'll have a good time uh, finding that out. Um, so yeah, that's it for today's session. I really hope you had a good time. If you have any queries or comments, feel free to put them in the comment section. I will respond as much as I can. Uh, and yeah, uh, so today's episode of Tech Talks ends here. Thank you so much for your time, and I will see you again. Bye bye.